Hi students, in this video we are going to see the special cases of graphical method. What is that special cases? So in these cases we may not get the optimal solution. Sometimes the region is not feasible. In some cases it is unbounded solution. So like this some special cases are there. In this video I will discuss the redundancy solution. What is the meaning of redundancy solution or redundancy constraint? Redundancy means that constraint is not contributing to the feasible solution. Redundancy solution means it's not contributing to the feasible solution. First of all, we see this with one example. Solve the following LPP by graphical method. Question is maximize z equal to 100x1 plus 40x2 subject to 5x1 plus 2x2 less than or equal to 1000. Second constraint x3 x1 plus 2x2 less than or equal to 900. x1 plus x2 less than or equal to 500, and we always call this is an objective, and this is the constraints we have, and at last given as non-negativity variables. So for this problem we have to find the solution by graphical method. Now we'll see first equation. We consider the first equation. Let 5x1 plus 2x2 equal to 1000, because in graphical method inequalities we used for shading the region. So to find the points we will use like this. So in equation 1 we substitute x1 equal to 0, and here if I substitute x1 0 in above equation I get x2 is 500. Same way, if I substitute x2 equal to 0, we can find what is the x1. So 5x1 is 1000. So x1 is 200. So this is the point 0, 500 and 200, 0. These are the points where this line cut the axis. So similarly, we will find the next point by considering the second equation. 3x2 plus 2x2. Inequalities is there, but to get the equation, to draw the equation, we'll have to take it as equal 900. Same way here also x1 0, our x2 is 440. So here the coordinates are 0, 450, and I am substituting x2 equal to 0 in the same equation. So 3x1 is 900 and x1 is 300. Therefore, the coordinate is 300, 0. So this line intersects the axis at 450, 300. The similar way, we will find the next one. That is x1 plus 2x2, which is less than or equal to 500. So here we will choose the equal symbol because we have to find where the lines intersect at the axis. So first we consider x1 0. So we got x2 value as 250 and x2 is 0, x1 is 500. So using all these points, we will draw a graph. Roughly, we will draw the graph. So first we consider the axis. So here I am roughly taking the axis, x-axis, and this is y-axis. Since in question all my values are greater than 0. So I have to plot it in the first quadrant. In this quadrant, all my values are positive. So first we plot the points. We roughly taken the points as 0, 100, 200, 300 like this. How we have to choose this one? Using our numbers present in the equations. So all are in hundreds and thousands. That's why we have to choose it as 100, 200, 300 and like this. We will choose up to 500 and here also 100, 200, 300, 400 and 500. So roughly using that first point, we plot the diagram. What is the first point means 0, 500. So which is nothing but here instead of x1 we will choose the variables given in the question. This is x1. Instead of y-axis we will choose x1, x2. And what about the points now? x1 is 0 and x2 is 500. This is the point we have to write like 0, 500. And next is 0, 200, 0. And this is 200, 0. Now roughly we join these two lines. And roughly we join these two lines. Equation of this line is 5x1 plus 2x2 equal to 1000. In next thing we will consider like a second constraint. So consider the second one. There also 0, 450. So in between this we will choose 0, 450 because it lies between 400 to 500 and another point is 0, 300. That is x2 is 0, x1 is 300. So this blue color points and we join that roughly like this. This equation is nothing but 3x1 plus 2x2 equal to 900. And the last constraint x1 plus 2x2 equal to 500. From that we get a 2 points. One is 0, 250. That is x1 is 0. Here I have that 250. So 0, 250. And another thing is 500 comma 0. So using these points, we get a roughly the straight line like this. Now we have to find the feasible region. In graphical method, we used to find feasible region by the intersection of all these constraints. Now we'll see that this constraint is less than, and second constraint is less than, third constraint is less than. Less than means this region we have to choose it. Below region. Now we will find all the three intersection place. So all the three intersection place is nothing but in this region. But this region, in this region, we have a four corner points. This region we will take, it's a bounded region, and we call this is a feasible region. But in this feasible region, this line, that is 3x1 plus 2x2 equal to 900, this line will not come in this place. It may give, that means the this region intersection of only 5x1 plus 2x2 equal to 1000 and x1 plus x2 equal to 500. The intersection of two lines only are there. The third line is not intersecting in this region. So we call this equation that is 3x1 plus 2x2, we call it as redundancy constraint. And if you find the corner points of this, four corners are there, we will take that as vertex. First one is 0 comma 0, and next is 200 comma 0, and we consider third point as intersection point. How to find the intersection? So solve this two equations. One is 5x1 plus 2x2 equal to 1000, and next is x1 plus 2x2 equal to 500. If you solve these two things, we get 125 comma 187.5. So we consider that is another corner point, and the last value is, we consider this corner point as C, which is 0 comma 250. For each and every vertex, find the value of Z. The value of Z is Z equal to 100x1 plus 40x2. So we got here 0, here is 20,000, here is also 20,000, and in this region it is 10,000. So two cases, 2 points is having the same values. So there is no optimal solution because it has an infinite number. We consider only two things, so we got a 20,000. If you are taking another points also, we will get another 20,000. So we don't have a solution for this. We call this as an infinite solution, but is not, this constraint is not contributing contributing to feasible solution. That's why it is called it as redundancy solution, redundancy constraint. Thank you. Thank you, student.